Another method for solving quadratic equations is the so-called completing the square method. So this method consists of applying a technique called completing the square. Um, and I'm gonna teach you how to do this by splitting the explanation in two parts. First, I'm going to tell you what the technique of completing the square is, and then we're going to do some examples where we apply the technique of completing the square to actually solve quadratic equations. Okay? So at the beginning, we're not going to solve any equation. We're just going to see how the completing the square works. Okay. So completing the square means to add a constant term, c, let's call it c, to a quadratic polynomial of the form x squared plus bx, so that when you add the c and you consider the new polynomial x squared plus bx plus c, that is actually the square of another polynomial, of more precisely a binomial, and it's going to look like this, right? So I'm adding c to my original polynomial x squared plus bx, and then when I add c, the trick is to add c in such a way that actually the new polynomial formed is the square of something, and it's going to look like this. It's going to be x plus this some number squared. So the idea is to figure out what c needs to be, and once we figure out what c is, what do we need to add, we get that this is the square of x plus d, and we need to know what d is as well. So we make it into the square of something, but the square of what? Turns out that this is actually pretty simple. As long as the coefficient of x squared is 1, which is what I have here, this is actually pretty simple. What do you have to add to make it into the square of something? What you have to add is this number right here. So this is what the c is supposed to be. The c is supposed to be b over 2. So basically you take the b, the coefficient of the x, without the x, take the b, divide it by 2, and square it. Whatever you get, that's what you should be adding to make this into the square of something. And once you add that, it becomes the square of what? Well, basically, it's going to be the square of this binomial x plus b over 2, all of that squared. Okay, so the number that goes inside this parentheses is what you get before squaring. So you take only the coefficient in the middle and divide it by 2. All right, when the coefficient of x squared is not 1, we first factor it out, then proceed as before, complete the square, and make a correction. And that's that case where the coefficient of x squared is not 1 is a little bit more complicated. So we're going to do a few examples where the coefficient is 1, which is the easier case, and then illustrate how to do it when the coefficient of x squared is not 1. But let's do the easy case first, when the coefficient of x squared is 1. Okay, so first one, x squared minus 10x. So let's complete this square. We're going to add something to that so that it becomes a square of something. So why do we need to add? Well, according to this, the number that we need to add is b over 2 squared. So we're going to take the coefficient of the x, which in this case is negative 10. We're going to divide it by 2, and we're going to square it. And that's what we have to add. Okay, so this is going to be x squared minus 10x. And then what do we need to add? We need to add negative 10 divided by 2 squared. Negative 10 divided by 2 squared. What is that? Negative 10 divided by 2 is negative 5. And when you add negative 5, when you square negative 5, you get 25. Okay, let me write this below. Okay, here. X squared minus 10x. We're going to take negative 10 divided by 2 and we're going to square that. Okay, what is that? You can put that in a calculator or you can do that in your head. That is negative 5 and then squared, that's 25. Okay, so basically what we need to add is 25. However, we don't really want to change the original polynomial. So you see, this means I'm adding 25, but you don't want to change this. So if I'm adding 25, I need to take away 25. So this is then going to become x squared minus 10x plus 25 minus 25. Because these are going to cancel each other off, which gives you 0. So that means if we were to simplify this, we don't want to do that. But if we were to simplify this, we will get back x squared minus 10x. All right. Okay. Now one last line. This right here, these three terms are the square of something, namely the square of x minus 5 squared. X minus 5 squared, because is going to be x plus whatever I divided by 2, basically this term before the squaring. This term before the squaring is negative 5. When you square it, you get 25, but before squaring is negative 5. So x minus 5, that's what goes inside the minus 5 squared minus 25. And that's how you complete the square. So you basically add a certain number and take it away, because if you didn't take it away, you're changing the original polynomial. You don't want to do that. Okay, so let's do another one. It says x squared, so that's the answer for this one. X squared minus 20x. Okay, so x squared minus 20x. So what do I need to add? We need to add negative 20 divided by 2, and you square that. So negative 20 divided by 2 is negative 10. And negative 10 squared is 100. Okay, take the number in the middle, divide it by 2, which is negative 10, square that, you get 100. So I'm adding 100, so I need to take away 100 because I don't want to change this. I don't want to alter the original polynomial. Okay, so then the first three become the square of something, namely the square of x minus 10. So remember that number that goes there is this one divided by 2, and then you have the square minus 100, and that completes the square. That's the answer for that one. Okay, let's do another one here. This one is not going to be a whole number. So x squared plus 9x. So what do we need to do? We need to add what? We need to add 9 over 2 squared. 9 over 2, so 9 over 2 squared. And how much is that? That is 81 over 4. So 81 over 4. So we're going to add 81 over 4, and we need to take away 81 over 4 so that we don't really alter the original polynomial. Now, these three are the square of something. The square of what? Well, it's going to be the square of x minus, and then the number that goes here is that divided by 2, which is a number that you square to get this one, but the number that goes there is that without the square. And then close parenthesis squared minus 81 over 4. And that's the completion of that square. That's it. So it takes like about a couple steps, usually. Okay, you should pause the video and attempt this one on your own, for sure. Okay, let's do it. So, what do we need to add? We take the number in the middle, which is negative 18. You divide by 2 and you square. So what is negative 18 divided by 2 squared? Negative 18 divided by 2 is negative 9. And then you square that, you get 81. So that means the number we're going to add is 81. So plus 81. And then you need to take away 81, because otherwise you change the original polynomial. And now this becomes the square of something, namely the square of x minus what? Is this number divided by 2. So this is going to be negative 9. So x minus 9 squared minus 81, which is this part. Okay, and that's it. So it's basically just 2 steps. As you can see. Okay, so that's it. Now we're going to do some where the coefficient of x squared is not 1. So the idea is the same, but we have to factor out the coefficient of the x squared first. So in this one, we're going to factor out the 4. Factor out the 4, and we're going to get x squared minus 2x. Okay, factor out the 4, the coefficient of the x squared, you're going to get x squared minus 2x. Okay, now we're going to ignore that 4 for a second, and we're just going to complete the square here. If you wanted to complete the square here, what do I need to do? You need to add, so you take the negative 2, you divide it by 2, negative 2 divided by 2 is negative 1, and you square that, negative 1 squared is plus 1. So that means I'm adding a 1. Right? However, when I add a 1, remember that we will need to take it away. When we add a 1, because this one is actually being multiplied by 4, I'm not actually adding a 1, I'm actually adding 4, because that 1 is affected by the 4 outside. So you're not really adding a 1 per se. Looking at the big picture, you're adding actually 4. So that means we need to take away a 4 from here instead of a 1. Okay, so that is the little trick here when the coefficient of x squared is not 1. You factor it out first, the coefficient of the x squared, and then you complete as before, but keep in mind that you're not really adding that number, you're adding that number multiplied by the coefficient outside, and that's what you need to take away. Alright, so now this is 4, and now this is the square of something, namely the square of what? The square of x minus 1, because the number that goes here is that one divided by 2, so negative 2 divided by 2 is negative 1, squared minus 4, and that is it. Okay, so that is the end of that. So it's just it's just one extra step. Okay, let's do another one. This one is 3x squared plus 12x. So the coefficient of x squared is not 1, so we're going to factor out that 3. You factor out the 3, and this is going to become x squared plus 4x. Okay, now you ignore the 3 for a second. So ignore that, and then complete the square of that. The procedure for completing the square of this, because now the coefficient of that squared is 1, because I'm ignoring the 3, so is 1x squared, is, as usual, is going to be, I take that number and divide it by 2, so 4 divided by 2 is 2, and then you square that. So That means I'm adding a 4. To complete that square, you add a 4. Negative is 4 divided by 2 squared, which is 4. So I'm adding a 4 here, but from the big picture, I'm not really adding a 4 because that 4 is being multiplied by that 3. It's affected by these 3 outside. So I'm actually adding a 12. So that means you need to take away a 12. All right? And now, this becomes a square of something, namely the square of what? It is the square of x plus 2, because remember, this number, again, is always just the number that you get when you divide that one by 2. So 4 divided by 2 is positive 2, so plus 2. And that is it. That's the end of that. All right. Now, you should try to do that one on your own. So pause the video and give it a shot. Okay, let's do it. So this is going to be, we're going to factor out the 4. So this is going to be x squared minus 4x. Now ignore that 4 and complete the square here. When you complete the square here, what you add, you take that number divided by 2 and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So plus 4. Okay, so you're adding a 4 here, but that 4 is actually affected by the 4 outside. So that means you're actually adding 16. So if you're adding 16, you need to take away 16. And now this becomes the square of what? That becomes the square of, that is the square of x minus 2, which is this number divided by 2. Negative 4 divided by 2 is negative 2, and then squared minus 16. Okay, so that's how the process or the technique of completing the square works. Now we want to do some examples where we use this idea to actually solve quadratic equations. Okay, so let's solve some quadratic equations by completing the square. So this method requires two things. That requires that we actually complete the square, just like we did, and follow that up with the square root property. So it's like we need to use actually two methods. In that order, okay? So first thing, you complete the square, then follow it up with the square root method or square root property. Okay, so let's do example 4a. So it says solve the following equations by completing the square. All right, you can solve this equation by factoring. We're just going to do it by completing the square to illustrate how the technique works. In practice, I'm not really too concerned whether, let's say, on homework or an exam, the instructions say complete the square to solve this equation, and you don't, and you solve it by another method. That's fine. Um, as long as you know how to solve a quadratic equation, that's really what I care about. But you got to know at least two methods. The most important methods are the factoring method and the quadratic formula. Okay, so this method is good, but is not the most important method. Okay, so let's do this example. All right, so what we're gonna do is first let's throw the 9 to the other side. So this is gonna become x squared minus 8x equals 9. Okay, so move the minus 9 to the other side. That's gonna be the first thing. because then I need these two, and I'm going to complete the square on the left-hand side. Okay, so let's complete the square. So what do we do to complete the square? We're going to take the number in the middle, divide it by 2, square that, that's what we're going to add. So negative 8 divided by 2 is negative 4. Negative 4 squared is 16. But if you add 16, you need to take away 16 because I don't want to change the left-hand side. Okay, now this becomes the square of what? Namely the square of x minus 4, because what goes here is this number divided by 2 squared minus 16 equals 9. So now move this to the other side. That's going to be x minus 4 squared equals 16 plus 9, that's 25. Okay, and completing the square is always going to take you to this spot where you have the square of something equals a number, which allows you to then follow this up and finish it off with the square root property of the square root method. Okay, now what do we do then? Now we take square root on both sides, and this is going to give us x minus 4 equals plus or minus the square root of 25, which simplifying means x minus 4 equals plus or minus 5. Okay, which means x equals, now move the 4 plus or minus 5. Now, we can simplify this. So we're not going to leave the answer like that because we can simplify this. That means there's two solutions. One is x plus 5, which actually equals 9. And the other solution is x minus 5, which actually equals negative 1. So the two answers are, let's write them here, x equals 9 and x equals negative 1. So those are the two solutions. Okay, so that's the first example on how to solve a quadratic equation by completing the square. As you can see, this is why most people don't really use this method as often, because you could have done this so much easier by just factoring. Look at this. If you try to factor that factor so easily as x minus 9, x plus 1, and then setting each factor equal to 0, you get x equals 9 and x equals negative 1. And that's it, which is the same thing as that. But this is so much easier and quicker than doing all that. That's why this method is not so popular, okay? But we need to go over it. Okay, so because this method actually is the one that begets the quadratic formula. That's why. All right, so let's do another example. So we're going to complete the square here. So how do we complete the square? We're going to get x squared minus 6x. What do we need to add to complete the square? So you take the number in the middle, which is negative 6 divided by 2, that's negative 3. Negative 3 squared is a 9. So you take the number in the middle, divide it by 2, and square that, that's what you add. Okay, you add a 9, take away the 9. You don't want to change things. Alright, so then this becomes x minus 3 squared, right? This number is that divided by 2, so negative 3 squared, minus 9 equals 16. And then we're going to throw this negative 9 to the other side, move it to the other side. We're going to get x minus 3 squared equals 25. All right, now square root property, take square root on both sides. You're going to get x minus 3. And remember that when you take square root on both sides, you have to put plus or minus. So plus or minus square root of 25, which simplifying means x minus 3 equals plus or minus 5. Okay, so that now move the 3, you get x equals 3 plus or minus 5, and this can be simplified. One possibility is x equals 3 plus 5, which equals 8. And the other possibility is 3 minus 5, which equals negative 2. So the solutions are 8 and negative 2. X equals 8 and x equals negative 2. Okay, and now let's do one last example of how to solve an equation by completing the square. All right, let's complete the square here on the left. What do we need to do? Add. We take the 10 divided by 2. That's 5. 5 squared is 25. So the number that we need to add here to complete the square here is 25. Right? Take the coefficient of x divided by 2 squared, 25. And then take it away because you don't want to alter the left-hand side. Okay, so you get 15. Equals 15. All right, now this is a square of what? That is a square of what? Well, is this number divided by 2, which is 5. So x plus 5 squared minus 25 equals 15. So now move the 15 to the other side. You get x plus 5 squared equals, what is 25 plus 15? I think that is 40. Take square root on both sides. The left becomes x plus 5. And on the right hand side, you have square root of 40, but don't forget to put plus or minus. Plus or minus the square root of 40. Okay, we can simplify that square root of 40 a little bit because square root of 40, you can break it up to simplify that radical. Square root of 40 is square root of 4 times 10, which is square root of 4, square root of 10, and then square root of 4 is 2. So this is 2 square root of 10. So you can simplify that, right? 2 square root of 10 instead. And then move the negative 5 to the other side, and you get negative 5 plus or minus 2 square root of 10. Plus or minus 2 square root of 10. And those are the two answers. If you want to write them separately, then you know that the two answers are negative 5 plus 2 square root of 10, and of course you cannot combine that, you cannot simplify that, and x equals negative 5 minus 2 square root of 10. Okay, so that's how you use the method for completing the square to solve quadratic equations.